Welcome back to the Drill podcast, where we tear down old school engineering and rebuild it with nature's blueprints. I'm your host, and today we're talking about radical departure from status quo of deep foundations. For decades, we've been slamming uniform steel cylinders into the dirt or pouring concrete into bored holes like we're playing a giant game of lawn darts. It's a method that worked since the Industrial Revolution. But let's be honest, it's rigid, it's inefficient, and it lacks the nuance required for a planet that's increasingly prone to seismic shifts and extreme weather. Nature solved this problem of anchoring high-impact structures millions of years ago. And the answer has been staring us in the face, literally, every time we look in the mirror. Teeth aren't just bone. They are masterclass in load distribution. Think about the molar. It's not just a single post. It's a multi-rooted tripod designed to withstand massive, repetitive, and often lateral grinding forces. Why are we still building skyscrapers on toothpicks when we should be planting them on molars? In this episode, we're diving into a dentition foundation model. Imagine a construction site where instead of standard pile driver, you see specialized rigs forming reinforced concrete roots that flare out into the bedrock. By mimicking the geometry of human dentition, we can achieve a design soil bearing pressures that shatters conventional limits. We're talking upwards of 16 to 21,000 psi. This isn't just a slight improvement. It's a categorical leap in how much weight a single foundation point can manage. But the real magic isn't just in the shape of a root. It's in suspension. Human teeth aren't fused directly to the jawbone. They're held by periodontal ligaments, a fibrous network that acts as a natural shock absorber. Our teeth pile uses a bio-inspired PDL interface, a semi-flexible high-performance sleeve between the pile and the soil. This allows the building to dissipate energy during an earthquake, rather than snapping under the tension of a rigid connection. When you look at the numbers, the safety data is staggering. Our current CAD models show a seismic factor of safety jumping from a standard 1.5 to a whopping 4.1. This global field response means that during a major event, the foundation field behaves like a collective organic unit, micro-adjusting to the tremors. We're moving away from the brute force philosophy of fighting the earth and towards a philosophy of moving with it, utilizing the same damping tech that keeps your teeth from shattering when you crunch on ice. Visually, these sites look like something out of a sci-fi epic. Instead of boring grid on dots, the foundation plan is a complex array of interlocking molar mapped specifically to the varying density of rock bed below. It's a futuristic landscape where heavy machinery is guided by holographic overlays, ensuring every root is perfectly seated. It's high-tech, high-pressure, and high-efficiency engineering that makes traditional driven pile look like ancient history. As we wrap up today's session, the takeaway is clear. The future of skylines starts in the jaw. We're finally learning that the most advanced tech isn't always something we invent in a lab. It's something we refine from the wild. The teeth pile isn't just a quirky idea. It's the evolution of stability. Thanks for tuning into the Drill podcast.